I welcome all on our first charity webinars. As you know, the situation in Ukraine is not very good, so that's why we want to help our army to be more better. And together with Scholar, one of the fund which organized by IT community in Ukraine, we raise money. So that this webinar is the first of the series webinars during which we try to raise money and help our Ukraine army. So you are welcome to donate during the links which we add under the video stream. It helps us to save lives of Ukrainian. And today with us, Alexey. He will talk about deployment deep learning model with Kubernetes and Kubeflow. He is a principal data scientist at OLX Group, and also he is a founder of one of the biggest, I think, European community of data scientists, DataTalks.Club, and he also organized different boot camps and help learning and studying data science for many people. Before I will give to him the microphone, please don't forget to join to our Slack channel and ask the question on it. We will. I hope we will have good discussion after the webinars. So come to the Slack. The links also under the video. And I give the microphone to Alex.
Yeah, thanks for a warm welcome, Dmitry. So I will now share my screen. So share screen. It should work, I hope. So the title for this talk is Deploying Deep Learning Models with Kubernetes and Kubeflow. I want to be a bit broader here, and I want to talk a bit about model deployment in general. So we will talk, most of the talk we will spend talking about Kubernetes, Keepflow, or it actually Caseserve now, but we'll get there. So a few words about me. I started my career as a Java developer, but then at some point I became interested in machine learning. So I did masters in Germany, and then I think I started working full-time as a data scientist 8 years ago, roughly 7 maybe, and then now I work at OLX Group. So if you're from Ukraine or from other countries where we're present, like Poland, Romania, Portugal, sorry, so probably heard about us. So we're a big online marketplace. This is like a place where you can go and sell things you don't need, or maybe if you want to buy something. So I work there as a principal data scientist. And in this talk, I will talk about my experience I picked up over my career. And this is actually based on a book I wrote. So the book is called Machine Learning Bookcamp. And in this book, so this book is for software engineers who are interested in becoming machine learning engineers. And there quite a few chapters are devoted to the topic of model deployment. And one of them is Kubernetes and Kubeflow. So actually, most of the material we will talk about here today is based on that. And another shameless plug is actually there is a free course that is based on the book that is called Machine Learning Zoomcamp. It's almost the same content, but in more interactive form. So if you enjoy this video, if you find it valuable, then you can check the course and you can learn more about most of the things I cover here today. So let me start with the plan. So the plan for today's webinar will be, first, we will talk about different options for model deployment. So we'll cover most of the, the ways I typically go about deploying a model. and then we will compare pros and cons of these different options. Then we will talk about Kubernetes, what is there, what kind of things are there, what it consists of. And then we will go through some code examples of how to actually deploy different models. So we will see how to deploy an XGBoost model, which is the simplest case. Then we will see how to deploy a Keras model with TensorFlow serving and Kubernetes, which is a more involved case. And finally, we will see how to use Caseserve. So in this, this webinar is called Deploying Models with Keepflow and Kubernetes and Kubeflow. But actually, what I will use here is a thing that was previously known as Keepflow serving, and now it goes by the name of Caseserve. I think they renamed it 1 year ago, but still I keep referring to this thing as Keepflow serving, but the proper way of saying would be Caseserve. So we will see how to use Caseserve. So that's roughly the plan, and let's start with the first thing, different options for model deployment. So on this slide, I have different, so I was just thinking, okay, what are the ways I usually deploy models? And I came up with this. So this is by no means an exhaustive list. There are many different ways of doing this. But the most typical way I do is I get a Flask application. Flask is a simple web service in Python. And then I put my model inside this Flask, and then I deploy this somewhere. One of the places where you can deploy your Flask application packaged in a Docker image, Docker container, is AWS Elastic Beanstalk. So Elastic Beanstalk makes it super easy, super simple to just do one command line command, like one command to deploy a model to the cloud. So it's super easy. Then another alternative is AWS Lambda, also known as serverless. We will talk about that. And then, so it's one of the simplest approaches. You don't need to worry about servers at all. Then another option would be the opposite of serverless, Kubernetes. And then we have options like Caseserve and AWS Sagemaker. And of course, like here, this slide is very focused on AWS because this is what I use at work. And actually at all the places where I worked as a data scientist, we used AWS, right? But there are also other cloud providers like Google Cloud Platform, like Azure, like other, I don't know, there is a cloud from Oracle, there is a cloud from IBM. There are many different clouds. And all of these clouds, most of them have similar services. So a service that is similar to SageMaker, or a service that is similar to EKS, which is managed Kubernetes. So even though like here, I kind of focus on AWS a little bit, but most of this stuff will be applicable to other cloud providers too. And I will start with the simplest one. So I will skip this Elastic Beanstalk. So if you want to learn more about the Elastic Beanstalk, maybe you can go to the course I mentioned. It's mlzoomcamp.com. And here we have this module 5 that talks about deployment. And here in this module, we show how to build a Flask application, how to put a model inside this Flask application, how to deploy it to Elastic Beanstalk, right? So I will skip that part. I will start with AWS Lambda. And I will open now my AWS console. And here, if I type Lambda, so what it says, so we see that the service is Lambda, and then it says run code without thinking about servers. And this is the main promise or goal of Lambda, is to make our life simpler and let us not worry about servers at all. So we just come up with a piece of code, we deploy it to Lambda, and Lambda will run this code somewhere, right? We can put the model inside this code, inside this Docker container, for example, put it on Lambda, and then when a Lambda gets a request, it will make sure that there is some environment where this code can be executed. So we don't need to worry about what this is. It will just magically appear for us, right? We don't need to worry about managing that. And that makes Lambda really cool because we don't need to think about all the EC2 instances and so on. And it works well up to a certain point, but with some load, this becomes expensive or hard to manage. Maybe you want to have more customization, right? And then this is where Kubernetes comes in, right? And in case of Kubernetes, So Kubernetes is the opposite of Lambda, if you will, right? So if Lambda is serverless, then Kubernetes would be air quotes server full, right? Because there are so many things. So in Lambda, we just take a piece of code, we deploy it to Lambda, and then it just handles everything for us, right? While in Kubernetes, we need to think about like all the moving parts inside Kubernetes. Like we need to know what a pod is, we need to know what a deployment is, we need to know what a service is. If you don't worry, we will talk about this later. But just to give you a high-level overview, there are many things that you need all of a sudden to worry about. And if you want to deploy a model, then you will need to go through all of these things, right? Yeah, this is where Caseserve helps us. Is instead of defining all these services, all these pods, deployments, and so on, we can just have one Kubernetes object to rule them all. So this is where Caseserve makes our lives easier. So instead of going deep in Kubernetes and then worrying about all these things, we can just tell Caseserve, okay, here is a model, take this, deploy this, and create a URL, and let us use this URL. So we will see this in action. But again, here for this thing, we need to have a Kubernetes server, right? A Kubernetes cluster. There are actually ways to deploy a model that do not require maintaining your own Kubernetes cluster. So things like AWS Sagemaker. So with AWS Sagemaker, you can just create an endpoint and then serve your model through this endpoint. It's good. You don't need to worry about servers. You just say, okay, for this model, I want to use this type of machine. Please deploy it. And it's quite cool until at the beginning of the next month, you get a bill from Sagemaker, and you open it, and you see, okay, now I have to, starve for the next month, right? Because Sagemaker is actually quite expensive. And last time I checked, I must admit it was a while ago, but last time I checked, it was 4 times more expensive than a similar plain EC2 instance, which means that just for using SageMaker, you need to pay 4 times more, which means if you have a lot of traffic that you need to deal with, then you're paying a lot of money to AWS, right? And that's why Kubernetes is a good option. It's a bit complex, but then it's cheaper, it's more flexible, and actually I think I have a slide that, how can I, yeah, I wanted to do this. So on this slide, I want to compare these 3 options I just talked about. So the first option is Lambda. So Lambda is good. It's very easy to manage. You just need to put your code somewhere. Usually it's a Docker image, and then you deploy it to Lambda, and then everything is good. And it works really well for small lot. If you don't have a lot of requests coming into your Lambda, then it's good. And you pay only for the time that your Lambda is actually computing something. If you're getting requests, you're paying for Lambda. If you're not getting requests, you're not paying for Lambda. It's really good. It's easy to manage. It's quite cheap for small loads. There are some downsides for Lambda. So with this, because it's a managed service, you don't always understand how things work inside. And sometimes your service all of a sudden can become slower and you have no idea why. And you need to contact support, and they will really not explain, but maybe they will help you to make it less slow. But this can happen, right? So it's not always transparent. You don't always have control over some things. So this is a downside. Then let us also look at SageMaker for serving. So SageMaker is also relatively easy to use and manage. You don't need to worry about all the moving parts like we have in Kubernetes. So we just have a machine on which we can deploy our model. We can also put our model in Docker and also deploy it to SageMaker. It works quite well. It's expensive, as I said, and it's also not very transparent sometimes because, again, this is a managed server. You cannot even if you want, you cannot really get into the internals of this. So then you just need to hope that it's actually working fine, right? No, so it's not transparent. And then another thing here, I didn't show you an actual example how to use SageMaker, But typically, you deploy the Sagemaker endpoint, and then you need to have a Lambda function that invokes the Sagemaker endpoint. So it needs some wrappers around that, which makes it a little bit difficult to use, right? But I mean, difficult, it's not that difficult, it's just a bit of extra overhead, right? But still, Sagemaker is a good option if you, let's say, need to deploy a GPU model and you don't have a lot of traffic. But if you have a lot of traffic, then both of these options are not good, because Sagemaker and Lambda will be both expensive. They are not always transparent, but Kubernetes is more flexible, and you can tune pretty much everything. So you have full control over how things work, provided that you have people who have experience of running and managing Kubernetes cluster. So for example, I am a data scientist. I do not have experience of managing Kubernetes cluster. So I know how to use it as a user. So I know how to create a service. I know how to create a deployment there. And I know that there are some people who will always help me if something doesn't work, right? So this is a good situation to be in, right? So if you have people who manage Kubernetes cluster and you can use it as a user, that's really great. But if you don't have people who can manage Kubernetes and explain why some things don't work and how you should do them differently, then you might end up being in a problem, right? So sometimes instead of that, maybe it's preferred to use a managed service in this case, if you don't have any people who know Kubernetes well. Yeah, it's quite flexible, as I say. It's a bit, well, not a bit, it's quite complex, right? Especially if you're coming from the data science background. So it requires support. And it's kind of cloud agnostic in a way that everything I say here you will be able to apply it to AWS, to Google Cloud Platform, to Azure, to any other cloud provider where you can run Kubernetes. So that's pretty cool. Okay, so for the rest of this talk, so here we discuss different options, like what we can use for deploying a model. So we talked when to use Lambda, when not to use Lambda, Sagemaker, and Kubernetes, right? And if you're, let's say, if you're looking for a job right now, and if you join a company, chances are pretty high that when you join this company, they will already have a Kubernetes cluster there, right? Usually mid-sized companies and larger size companies, they already have a Kubernetes cluster. They already use Kubernetes cluster. They already have people, at least one person or two, who know how to manage Kubernetes clusters. It's pretty common technology. Many companies use it. That's why actually I wanted to, in this talk, I wanted to talk more about Kubernetes and tell you how to use it for deploying machine learning models. So let's start. So I will start with drawing. So I will go back to the slide. So right now I just want to talk about Kubernetes. So what Kubernetes is and what are the components of a Kubernetes cluster. And I will start with, so sadly today I usually use stylus for writing. So I have like a special pen for writing on the screen. Today I use a usual laptop that doesn't have a touch screen, that I don't have a stylus. So I will use what I have. I will use the simple shapes from Google Slides. And I will start with a Kubernetes cluster. So this thing, I'll make it white. So this is our Kubernetes cluster, right? And then let's say we have a user. So it could be a user of our website, or I don't know, some user, maybe some external client, or maybe some other team that want to use some of the services that we have in Kubernetes cluster. So they send a request, and usually this request is sent to a thing called ingress. So in Kubernetes cluster, an ingress is some sort of gateway to our cluster. So all the incoming requests outside of the cluster, they come through this common gateway through ingress, right? And inside this Kubernetes cluster, we have the actual machines where things are running. So these machines are called nodes. So let me create, so I'll have two nodes here. So that will be node 1. I'll call it node 1 and node 2. Right? So if you think about AWS, so that would be our EC2 instances, right? So this is just the computers where we can run things. And these as EC2 machines, they can have some instance type, like certain amount of RAM, certain amount of CPUs. And on these machines, on these nodes, we can have pods. So let me first make it, I'll make it, I don't know, maybe white too. So on these nodes, we have things called pods. So pod, so just create a few pods. So a pod is a thing that is running on the node and it's running what we need. So let's say if we have a web service with our machine learning application and we have a Docker image with this service. So this pod would be a single, like the simplest unit here. This is the actual Docker image, if you will, right? So let's say these are, if we have a service with, I don't know, a Flask service, then we can have multiple instances of the same service running on the same node. And then maybe we can have something else running on node 2, and then maybe we can have something else running again on the same node. And then, yeah, so because a node can have a bunch of resources, so it can have, I don't know, let's say 16 gigs of RAM, right? And this pod needs only 500 megabytes of RAM. This one needs, I don't know, 1 gigabyte of RAM, so we can have multiple pods on one node. And then we can create more and more pods until we run out of resources on this node. So we have pods, we have nodes, and then the nodes, so the pods, let's say this pod and this pod, they contain the same Docker image, right? So the same application we have. And this one also contains the same one. So we usually group them into deployment. So let's say all these things, they contain the same image. So this is deployment, and I'll just make it yellow. Yeah, so that would be a deployment, right? So these things, so deployment is a bunch of pods that contain the same image, that contain the same service, right? So that so here I use the term service, which is a bit ambiguous because we inside Kubernetes we also have services. But anyways, so this is a thing, a Flask application, multiple instances of that. So we group these pods into one single thing, and this thing is called deployment, right? And here maybe we have another deployment with different set of pods, right? So maybe it's a different thing. And yeah, let's say this is our model and the user is sending a request to our model. And then the request is actually, instead of going directly to the deployment, instead of going directly to the pod, it goes first to a service. So let me put it here. Service. Actually, I think services also live on pods or on nodes, but here for simplicity, I'll just put them somehow a bit outside. And then what the service is doing. So let's say we get a request. So try to draw a little bit. So we get a request. So it goes through ingress and then goes to service. Right. And then the service needs to decide. So because we have multiple pods, we have pod 1, 2, 3, right? So the service needs to route the request to one of these pods. So usually it just randomly selects to which pod to route. And then let's say it selects this pod. And then it knows that this service knows that in this deployment, these are all the pods, right? And then it just randomly selects which pod to route the request to. Right? And then this service is an external service because it is accessible outside of the cluster. So the client outside of the cluster can reach this service and then can reach the pod. But some of the services can be internal services, right? And these services cannot be reached from outside. So this client cannot send the request to this internal service. For example, this node here, this pod, can send a request to this internal service, right? And then internal service will route the request to one of the pods here, right? So this is how roughly it looks like. And then imagine we're getting a lot of traffic. So I don't know, maybe it's rush hour and everyone is checking our website. And yeah, these 3 pods that we have, so they are all identical, but they cannot cope with the load. There's just too much requests, too many requests. So what we can do is we can scale our deployment. We can add more pods to that, to the deployment. So let's say we can create another pod in another node, right? And if we run out of nodes, Kubernetes will automatically create another node, and then it will create another pod on that new node, right? So it can scale up. And so we can add more pods as we need. And then when the traffic goes away, when the traffic declines, we can just reduce the number of pods we have to remove one extra one, because now the load is gone. We can just have fewer nodes. And yeah, that's roughly Kubernetes. Of course, there is more to that, but I think the most important things are to know our pods, nodes, services, and deployments, right? Ingress to some extent too. So here is the summary. So pod is an instance of the thing we want to deploy. So usually, roughly a pod corresponds to a Docker image. Then deployment is a group of pods. So, and usually all the pods in one deployment are exactly the replicas of each other. They're same. Then this thing, when I talked about scaling up and down to cope with traffic, is called horizontal autoscaling. And the thing called HPA, horizontal pod autoscaler, helps to get more nodes when there is traffic, right? Then a node is a EC2 instance, and the service is a thing that routes the requests coming from users, from the clients, or from internal services to one of the pods in the deployment, right? And then ingress is the kind of gateway to our cluster. So that's roughly the main things inside Kubernetes, right? So I know it could be confusing, but yeah, you can always come back to this and maybe rewatch it. And also in the book, I cover this in text form if it's easier for you. But yeah, that's roughly it. So for this talk specifically, we will need to know about deployment. And inside deployment, we will specify how each pod should look like, how all the pods will look like inside this deployment. And we will specify a service. And actually, I think the next part, the next section of this is now we saw like sort of the theory. We know a little bit how Kubernetes looks like. Now let's spend some time looking at the actual code. So I will not do the code here, even though I actually can. I have the Visual Studio. I will show a demo at the end, so you will see some code. But here I have code on the slides, so I will show you the slides. Maybe it's not as interesting as watching me live coding me live, but still it should give you some idea of what's happening. So yeah, we discussed that, and now we want to see how we can use all that, everything we talked about Kubernetes. How can we use it for deploying a Flask application? So the Flask application that we will have will serve an XGBoost model. So XGBoost model is a model like a tree-based model. So it's a separate library called XGBoost, right? So let's imagine a scenario where a data scientist, or I don't know, where we have a notebook for training the model, and then at the end of this notebook, we take the model and we save it, right? So we have some model artifact, and then we want to take this artifact and we want to start serving it. We want to create a web service that will receive requests from users, right, from clients, and it will reply them with predictions. I don't know, it could be any model, right? Doesn't matter what model is inside. So we can have that, right? So we have that, and now we want to deploy this. And the way we do it with Flask is we just define a function called predict, and then we put a decorator on top of this function, and then with this decorator, this function turns into a web endpoint, and now it can receive post requests with our features. So here we get the features in JSON as a post request. We get these features, we apply the model to these features. We get some predictions, and then we return back the predictions. So it's quite simple. Of course, here on this slide, we don't see a lot of code. Most of the code is missing. Maybe I can quickly show you how fully working code looks like. So again, this is a toy example, but still a little bit bigger. So in this example, we load I think it's a logistic regression model. And then here inside this Flask obligation, we get the prediction. So here we are predicting churn, if a customer is going to stop using the services of our company or not, right? So a customer, these are the features, and then we apply the model, and then we return some predictions. And so this Flask service returns the predictions of the model for the request for the client, for the customer, right? So this is a model like that. And then now, in order to deploy it to Kubernetes, we need to package this in Docker, right? And the typical Docker file can look like that. So we install all the dependencies. Now, in practice, instead of pip, you will probably use something like pipenv for poetry for managing dependencies. So you install all the dependencies inside your Docker image, then you copy the code. So this model.py is this file. So you copy this file, you might have other files, so you copy all them to your Docker image, and then because this one, it's running on the port 9696, so we want to expose this port, and then instead of using Flask, which is only like it's basically we need to use an VSGI server for running the Flask application. So we typically use gUnicorn for that. Yeah, here it's not super important. So this is just, we have Flask, we have gUnicorn for serving the Flask application, and we have XGBoost. We install that, we get the code, and this is the command we use for running this service. So this is the Docker image we have. Then we build this Docker image, then we publish this Docker image. And actually, if we use AWS, so in AWS, we usually publish it to ECR. So ECR is Elastic Container Registry. So this is the place where we can keep all our Docker images, right? So here we build this image and we publish it to ECR. And once it's there, we define a deployment. So a deployment looks like that. So at the first glance, it might look a bit scary, but there is a lot of metadata information. So let me go line by line. So the first one is not interesting, but the second one tells that this YAML file is a deployment. So remember, we were talking about deployments, right? So it says that this is a deployment, and this part, so template, this describes how each pod in this deployment will look like. So this template is a template for a pod, right? So it says that for this pod, the spec for the containers of this pod should be like, we need to get an image from this location, and this is something we deployed with ECR, right? Then, yeah, so this is the image, the Docker image. Then this is the port that this Docker container exposes. Remember, we exposed this port here, and then we have this gUnicorn application running on this port. So we need to expose this port on this container, and we do it here. And yeah, we have some configuration here. So let's say if we keep our model on S3, we need to tell the service where to download the model. So we can specify some environment variables here. And then finally, we have these replicas. So replicas is we tell the deployment, we tell Kubernetes how many pods for this deployment we want to have, right? So right now, I say that I want to have only one pod for this deployment. And the rest is just some technical information, like what is the name of this deployment, what kind of tags we want to assign. And actually, this tags will be important later when we talk about services. But yeah, it's just, I can see this as visual noise. It kind of distracts you from the important parts, which are here. So this is the important part, which describes what is the container that we want to run for this, how exactly the pod looks like. And so this is how a deployment looks like. And once we have a deployment, we create a service. So remember a service, I'll go back here. So this is the deployment, and the template in the deployment describes how each pod looks like. And now we need a service. A service routes the requests to one of the pods, right? Either to this one, or this one. So for that, we need to specify this to create this other kind of Kubernetes object, which is a service. And you see this selector, right? So this selector says that all the pods that have a tag called app that is equal to XGB model, which is this one, right? So it says route the request to one of these pods that match this criteria. Right? So this is how you link a service and a deployment through these tags. So this is the selector. So this is how we tell service to route where to route the request to. Then another thing that could be interesting and important for us is this port. So for the port on the service, we use port 80. So when the user sends a request to the service, they will use port 80 in the service URL. But then when the service routes the request, it will route it to the port 9696, right? And yeah, one last thing is the type of the service. It's load balancer. Remember here, some of the services can be internal, some of the services can be external. So a load balancer is an external service. So this service is reachable by clients outside of the cluster. But internal services are not. So if we want to create an internal service, we just drop the type from here. In this case, we create an external one. That's why the type is load balancer. And we define these YAML files, and we execute two commands. So the first command is kubectl. kubectl is a tool that we use for interacting with the Kubernetes cluster. So we do kubectl apply -f and then point to the file. So this file is the first file, then service YAML is the second file. So you just execute these two commands, and then you have your service running in Kubernetes. So that's roughly it. So now I need to, I've been talking too much. I need to catch my breath. Yeah. So, so far so good, I hope. Yeah, so this is how we deploy simple services. And I see that we don't have a lot of time left. So maybe I will speed this up a little bit. So I will skip a few slides. So yeah, so here we have figured out how to deploy a simple Flask application with Kubernetes. And maybe, yeah, I will stay in this mode, so I will not go full screen. So usually when we have a deep learning model, so let's say we use Keras for a deep learning model, for creating a deep learning model. And the model we can think about here is a model for classifying images of clothes. So imagine you have a picture of a t-shirt, and then you send this picture of t-shirt or of pants to the model, and then the model replies with the prediction saying, okay, it seems like you have pants on this picture. So this is the model we want to deploy. So usually after you train your model in a notebook, you end up with an H5 file, right? So this is usually what you use for training Keras models. And then in order to use it, in order to deploy it, you need to convert it to saved model. So the reason you need to do this is we don't typically use Keras for serving models. So we use Keras for training, but for serving, we use tools like TensorFlow serving. And that's why we need to take our H5 model and we need to convert it to a format that TensorFlow serving recognizes. And this format is saved model format. And usually the code for converting from H5 to saved model is relatively straightforward. You load the model in one format, you save it in another format. So that's pretty simple. Once you have that, you have this saved model stored in this format, right? And in this, so this is the folder with the model. So instead of one file, like in Keras, you have multiple files. Yeah, maybe it's not super important what these files are, but what is usually interesting is to look what kind of model inside. So here variables are the weights of the models, and I think this saved model is the architecture of the model. And we have some signatures here, I don't know, probably here too. And then we can look inside what we actually saved with a special tool that comes together with the TensorFlow. The tool is called Saved Model CLI. So using this model, you can see what is inside. And here we see that this model is expecting, so this is the input, right? So this model is expecting an image of this shape 299 by 299, and then the output is prediction with 10 classes, right? So we have 10 different classes of images. That is the prediction. And then you will actually need it a bit later. We will need to use this information: the signature, the name of the signature, the input, and the name of the output. So now we have the saved model, and we use TensorFlow serving for serving this model. And the simplest way of doing this locally is just run it inside Docker, and then tell Docker, okay, we want to run this specific image, TensorFlow serving, and then we want to take the directory with the model that we have here, and we want to map it to the directory inside the container. And with just this command, with, I don't know, 1, 2, 3, 5 lines of code, we can run TensorFlow serving on our computer. So this serves our model that we created with Keras. Right, and then it listens for requests on this port. So we can see that this is the output of the model. And yeah, so this is where the requests will be coming in. So we will use gRPC for that. And gRPC is like a special binary format for efficient communication. So there are formats like JSON, which are text-based format, and there are formats like gRPC, which are binary formats. And for deep learning, because we're sending a lot of data, like NumPy arrays, then typically gRPC is preferred because it's much more compact than JSON. So we need to install a few things. So we need to have a client for gRPC, and we need to have a client for communicating with TensorFlow serving. And then we come up with a code like that. It's a little bit like it might be difficult to understand what's happening here. But let me just quickly explain you. So maybe like here we prepare a request in gRPC format in protobuf to communicate with our the model we deployed here. So here we deployed the model. Now we want to communicate to this model and send it an image for predicting, right? And this is how the code looks like. So here we need to know the name of the model. So it comes from here. So here we specify the name of the model. So we need to say when we make a request to which model we make a request. So here we say that. Then signature name is something we can see here. So we go back to when we explore the model. So we see that this is the name of the signature. So yeah, we just need to get this information. Without it, we will not be able to query our model. All right, the next thing we need to do is the name of the input. So this is where we have our image. We prepared this image. We converted it to NumPy array. So it lives in our capital X variable. Now we need to package this inside protobuf, and we need to put it inside this input 8 variable. This input 8, we can see the name from here, right? When we inspect our model, we can see what are the names of the inputs, what are the names of the outputs. And by the way, this is so here we make the request, and here this is the response, right? So this is how we roughly do this. So now we need to put this code somewhere, right? So we already have the model itself here. It's running in TensorFlow, and now we need to put somewhere the code for downloading the image, for converting it to NumPy array, for converting it to protobuf, to communicate with this TensorFlow serving. Right, and then so what we do is we take this code that I just showed you, and then we put it inside Flask, And then when we want to make a prediction, let's say we have an image of pants, then we send the URL to our gateway service that contains this code that I just showed. Then it resizes the image, it converts it to NumPy, converts it to protobuf, and then sends this over gRPC, right? And then, yeah, we have the model. We apply the model, and we send the predictions back to this thing, to the gateway. These are raw predictions. We need to prepare these predictions to post-process them, and then we send it to the user. And we say, okay, this looks like pants. Right, so we need to, instead of having a simple one thing, we now have two things. And we need to deploy them. And yeah, there are some gotchas here. So we don't want to have a dependency to TensorFlow. And I see that we don't have a lot of time, so I will not spend a lot of time here. I will just say that at the point where you need to deploy this, go through these two links. So they will explain you how to get rid of the TensorFlow dependency and how to make your Docker image much smaller, right? And once we have that, we take our model in the saved model format, we put it inside a Docker image, we publish it to ECR, then we take the code that this gateway service, right? We also package it into Docker, we build it, we publish it to ECR again, and now we want to deploy it with Kubernetes, right? So now, instead of having one deployment and one service, we will have to have two services and two deployments, one for TensorFlow serving, another one for the gateway service. Okay, let's see how to do this. So it's very similar. So this one, the first deployment for TensorFlow serving, it's very similar to what we did previously. So this is the image where we published our TensorFlow serving model. And yeah, so here we just specified, right? And then the container port is this one, the same one we, so here, we used here, right? So this is the port that our TensorFlow serving uses, right? So, and then we create a service. So this service is, you see, we don't specify the type, like it's not a load balancer. So this one is an internal service. It's not possible to reach to this service outside of the cluster, right? And so this is for the TensorFlow serving component. We use kubectl to apply this. And then the next one, so now we applied the TensorFlow serving part, and now we need to deploy the gateway part. So the gateway part, let me remind you, it gets the image, it processes it, and then it uses gRPC to communicate to the TensorFlow serving, right? So here, the important part is we need to know how exactly these two servers can talk to each other. So the gateway service needs to find the Kubernetes, the TensorFlow serving service, right? And we need to give it a URL, right? So each service has an internal URL, and the URL looks like that. So first, all the services, the URLs end with cluster.local, and then it's always SVC. SVC is short for service. And then this is the namespace where the service is running. We didn't cover namespaces. That's why the default one is always the default one, right? And then this is the name of the service. So if we go back, so this is the name of the service we defined. So that's why the URL that we use for contacting this service is this one. So this is how the URLs are built, internal URLs. And then it's this 8500. This is the port where TensorFlow serving is listening for gRPC connections. And yeah, the rest is very similar to what we did before. So here, the important part, the gateway, if I go back to this picture, so the gateway needs to know how to contact this thing, this other part of our model, right? Where the actual model is running. So that's why it needs to know the URL. And what internally is happening is exactly this. So a customer client will send the image of pants to the gateway service, and then the gateway service will select which pod to route the request to. So it will route it here. And then here we are downloading the image, we are pre-processing the image, and we are sending this protobuf file that we protobuf request that we have at the end to the TensorFlow serving service, which is internal, right? And then what it's doing, it's randomly routing it to one of the pods here. Right? So this is, and then of course this one replies with the predictions, and then you post-process these predictions and send it to the user. So I know that I was very fast when I was talking about this, and I see I'm just looking at the time, I see that we don't have a lot of time left. So I just want to show you where you can find more information about this, and maybe you can take it a bit slower. So in the course page, which is mlzoomcamp.com, there is this module Kubernetes, right? So in this module, everything I described, all the code, everything is here. So you can just go back there when you want to learn more about these things and learn about this. Okay, and yeah, there is one thing that you will notice. I will just skip this slide. When you actually want to deploy this in production, check this article. So I'll just quickly jump over this, and I want to spend the remaining 6 minutes that I have talking about Caseserve. So Caseserve is a thing you can think of this as a plugin for Kubernetes. And you probably realized, like, with all these YAML files, I spent I don't know how much time explaining what these YAML files are, like what is service, what is pod, and like for each thing we want to deploy, we need to come up with a YAML file for deployment, we need to come up with a YAML file for service, and it just becomes too much at some point, right? Or if all we want to do is just create, just serve a model, maybe this is too much, right? We don't necessarily need it to put it in a Flask application. Like there is a lot of overhead. So what Caseserve is doing, it makes this process simpler. So instead of all the pods, all the deployments, we just have one Kubernetes object that is called Inference Service, and then internally it creates pods, it creates deployments, it creates services, it creates all that, right? And then it gives a nice URL. And the way, the way it looks like, so let me just show you. This is how a Kubernetes, like a YAML, looks like. It's pretty simple. So this one is a Kubernetes TensorFlow model, right? So we just say, okay, our model lives here. And that's pretty much it. So we give it a name. So the name is TF model. And this is where the model is. And that's pretty much it. And then we just apply this model and we're good, right? So Keepflow, Caseserve, takes care of all these things of creating pods, of creating deployments. And when it comes to the thing we discussed, so here, remember, we had to we needed to have this gateway, we needed to have a model, and Keepflow actually helps with that too. So here in Keepflow, we have a thing called transformers, right? So with Keepflow, with Caseserve, I keep saying Keepflow, but I actually mean Caseserve. So with Caseserve, when you send a request to a model, first, if you want, it will be sent to a transformer. So transformer gets a raw request and transforms it to the format that the model is expecting. So here, practically what it means, that we get the model, or we get the image of pens, and we turn this image into a NumPy array, and then we do some, I don't know, resizing and so on, turn it into NumPy array, and then send it to the model. And it's not KFServing, but Caseserve, right? Then the actual model is served with Caseserve, which is, I think internally it actually uses TensorFlow serving. Then it applies the model to the pre-processed data and replies back with raw predictions. And then we have another transformer for post-processing that takes care of converting this into the reply that the users get at the end. So I went super fast over this, but like here, I just want to share the link with you. So this is one of the repos I have in my GitHub. So it's called Keepflow Deep Learning. That explains everything that you need to do in order to have your to deploy your model with Caseserve. So starting from like creating a Kubernetes cluster, then configuring a domain, then like basically everything you need to do in order to deploy a model. So
yeah, I share this link in Slack channel, so if you are in, you can
thank you.
get this link.
Yes, and I want to spend 2 minutes that I still have on a short demo. So right now I am in, so I cloned this repo. So this one, right? So this is the repo. And what I want to do is I want to deploy a model that looks like this. So let me show you how it looks like. So this is the YAML file we have. So here we have the predictor, the TensorFlow model for classifying images of clothes, right? So this model lives in this location on S3. And then we have a transformer. So this transformer gets in the URL. It's actually another project. I have a link in slides. I don't have time to explain what exactly it's doing, or not what, but how exactly it's doing. But what it's doing, it's getting an image, and then it's converting it to this size. So image of any size will be resized to this one, and then it will apply certain preprocessing, and these are the labels for the output. So there is some post-processing and pre-processing that is done by this transformer. And then we have the predictor. And now I want to deploy this model. So what I do, I already have a Kubernetes cluster running. So it's actually, if I go to AKS, so I have a cluster running here. It has 2 nodes, I think. And now I want to deploy this model. So I'll do kubectl apply -f, and then this file. So now this was applied, hopefully. Yeah, cool. Now we can check what's happening here. So I do kubectl. So the Kubernetes object it just created is Inference Service. So here I'll do kubectl get Inference Service. And this way we can see what kind of inference services we have right now. And we have this Kubernetes, this inference service. You see, we already have it running on a special URL. So it's clothingmodel.default.kubeflow.mlbookcamp.com. So I already configured Caseserve. That's why I can use this domain. And I have a special file that is called test transformer, which what it's doing, this is the request it's sending. And this is the URL where it is sending this request. So it just prepares a request and then it sends to this URL, clothing model, default, Kubeflow, mlbookcamp.com, and then the rest, right? And then it prints the response. And now I will just execute this. And hopefully it should work. Yeah, so it is working. So here we have predictions. So for the image we have, let me show you what the image is. So it should be pants. Yeah, so this is the image of pants, right? And then the response is that, so there are some scores, and then for the pants, we have the highest score. So here we deploy the model, and instead of having a ton of different YAML files, we have a YAML file that is way shorter. Okay, I realized now it was actually not possible to cram a lot of content. I was probably too ambitious when preparing for the talk. Yeah, I hope it was still useful for you. You can, like all the resources that you need are in the slides, and I shared the link to the slides with Dmitry, so he will probably post it in Slack.
Yeah, and, we will share.
Yeah. I think I am done. Sorry for, like I heard you didn't fall asleep.
Okay. Thank you for your presentation. Now we can continue in the Slack, and I invite all to our Slack channel. So let's ask the question on the Slack, and we will answer for it. And thanks for all who was with us today and who donate also for to do donation. See you on next webinars. Thank you, and see you on the Slack and on the next webinars.
Thanks for inviting me. Goodbye.